Imagine you're floating through space. No traffic, no homework, no notifications. Just you, the infinite universe, and absolutely nothing going wrong. Until you notice something in front of you. A black hole. And for some reason, instead of thinking, that seems dangerous, you think, I wonder what happens if I get closer. Congratulations. You've just made the worst travel decision in human history. But what would actually happen if you fell into a black hole? Would you get sucked in immediately? Would you get crushed? Would you somehow survive? And most importantly, would you even be able to see yourself fall into it? Let's find out. First, let's clear up one thing. A black hole isn't literally a giant hole in space. It's an enormous amount of matter compressed into an incredibly small region, creating gravity so strong that, beyond a certain point, nothing can escape, not even light. And that point is called the event horizon. Think of the event horizon as the universe's worst possible boundary line. Once you cross it, there is no going back. No U-turn, no emergency exit, no button that says, actually, I changed my mind. You're committed. But here's where things get interesting. If you're still far away from the black hole, you don't necessarily feel some giant cosmic vacuum cleaner pulling you toward it. From a distance, a black hole's gravity behaves much like the gravity of any other object with the same mass. So if, somehow, the sun were replaced by a black hole with exactly the same mass, Earth wouldn't immediately get sucked into it. We'd still orbit it. The problem would be that we'd lose sunlight. So we'd basically get the worst possible combination: freezing temperatures and a giant invisible object where the sun used to be. Great. Now let's say you've ignored every survival instinct you have and you're actually heading toward the black hole. At first, you might not notice anything unusual. You're falling faster and faster, but that's not necessarily the weirdest part. The weird part is what happens to time. Imagine you're wearing a watch. From your perspective, the watch works normally. 1 second passes, then another, then another. Nothing feels strange. But someone watching you from far away would see something completely different. As you approach the event horizon, they would see your movements appear to slow down, and slow down, and slow down. You'd appear to get closer and closer to the event horizon, but never quite cross it. To the distant observer, you would seem to freeze near the edge of the black hole while the light coming from you becomes increasingly red and faint. Eventually, you'd disappear. So from their perspective, you never actually seem to enter the black hole. But from your perspective, you absolutely do. And this is where things get very weird, because you wouldn't feel yourself slowing down. Your clock would keep ticking normally. You would cross the event horizon in a finite amount of your own time. And here's the terrifying part. You wouldn't see a giant wall. There isn't a glowing cosmic sign saying, "Welcome to the event horizon." You just cross an invisible boundary and continue falling. Now, maybe you're thinking, okay, but what if I turn around? No, this is where the black hole stops negotiating. Once you're outside the event horizon, technically, escape is possible if you have enough energy and the right trajectory. But once you're inside, every possible path forward leads deeper into the black hole. It's not just that your spaceship isn't powerful enough. It's not a matter of, I need bigger engines. The geometry of space-time itself has changed. All possible futures lead inward. Imagine standing on a moving walkway that only goes one direction. You can walk against it. You can run. You can bring the world's fastest treadmill shoes. But eventually, the walkway wins. Except with a black hole, the moving walkway is basically space-time, and it has a much better engine than you do. Now we get to the part you've probably heard about: spaghettification. Yes, that is actually the name scientists use. And honestly, scientists could have picked something a little more comforting, but the name makes sense. As you fall toward a black hole, the gravitational force acting on the part of your body closest to the black hole can become dramatically stronger than the force acting on the part farthest away. So your feet could be pulled much more strongly than your head. And that difference in gravity creates enormous stretching forces. You'd be stretched vertically, while simultaneously being compressed from the sides. Basically, the black hole is taking the human body and asking, how long can this thing be? The answer is, not very long. But there's an important detail. Whether you get spaghettified before or after crossing the event horizon depends on the size of the black hole. And this is where black holes get even stranger. If you're falling toward a relatively small black hole, the difference in gravity between your head and feet can become enormous before you even reach the event horizon. Which means you are having a very bad day before crossing the point of no return. But a supermassive black hole is different. These monsters can contain millions or even billions of times the mass of the sun. And because the event horizon is so enormous, the gravitational difference across your body near the event horizon can actually be much smaller. So, theoretically, you could cross the event horizon of a supermassive black hole without immediately noticing anything dramatic. Which is honestly ridiculous. Imagine falling through the most dangerous boundary in the universe, and your body is basically seems normal. Meanwhile, the universe is like, no, you're definitely not coming back. Now let's talk about what you'd actually see while falling in. Because space around a black hole isn't just going to look like a giant black circle. If there's glowing gas around the black hole, that material can orbit incredibly quickly and become extremely hot. So you'd see a bright, distorted disk of matter around the darkness. And because gravity bends light, the black hole would also distort the appearance of objects behind it. You could potentially see light from parts of the universe that would normally be hidden from your view. The black hole basically acts like the universe's most powerful and most terrifying funhouse mirror. Except instead of making your head look enormous, it bends the path of light itself. And as you fall deeper, the outside universe would appear increasingly distorted. Eventually, though, things get much worse. If this is a simple, non-rotating black hole, classical general relativity predicts that you'd eventually reach the singularity. This is the point where our current understanding of physics stops giving us a complete answer. And that's important. Scientists don't actually know what happens to you at the center of a black hole. Our existing theories predict extreme conditions where the equations break down. That doesn't necessarily mean there's literally a tiny point of infinite density sitting there exactly as our equations describe. It means our physics isn't finished. We need a theory that combines gravity with quantum mechanics to understand what truly happens. And that's one of the biggest mysteries in modern physics. So if you were hoping I'd tell you exactly what happens when you reach the center, I can't, and neither can anyone else, because the universe basically reached the end of the instruction manual and said figure it out. But there's one last thing that makes black holes especially strange. From your perspective, you fall across the event horizon in a normal amount of time. From the perspective of someone far away, they never see you cross it. Both descriptions come from the same laws of physics. And that's the part that makes black holes so fascinating. They're not just giant cosmic monsters. They're places where gravity becomes so extreme that our normal ideas about space, time, and cause and effect start behaving in ways that feel completely impossible. So, if you ever find yourself floating through space and notice a black hole getting closer, don't panic. Don't scream. Don't try to turn around. Just remember, you should have probably taken the other route. And if you enjoyed watching a human being make increasingly terrible decisions in the name of science, subscribe. Because there's a lot more in the universe that can kill you in ways you haven't even considered yet.